In previous videos, we've talked about problems with spreadsheets and how to address them with testing. But spreadsheets just aren't always the right solutions. There are problems that you can come up with in your work that are just not solvable with a spreadsheet. And those are the type of problems that we're going to talk about today, when not to use a spreadsheet. So over the past few weeks, you've learned a lot about me and the things I like teaching and craft beer. But there's one of my hobbies that we haven't talked about, and that's going to the movies. I really like the movies. I even have a subscription to the movie theater in my city that I can go to all movies unlimited. So this week's exercises will be all about a little movie database I've made in a spreadsheet where we have movies, the studios that made the movies, the rating of the movie, so when you can see it, the year that the movie has been released in, and the type of movie, the genre, so an action adventure, and we have a lot of data. And in addition to the movies in our database, we also have actors and the movies that they have played in. So here you can see that Android 3000 has played in a volcano movie. So this is a nice little database with movie information that we can analyze. So there are lots of analyses we could do on this data. For instance, we could analyze the studios that actors have worked for. We could be interested in the question, what actor in our database has worked for the highest number of different studios? So we can get the information in from a studio with a VLOOKUP. This should all be easy for you if you've watched all of the videos. So we add a VLOOKUP and we get the information of every studio associated with a movie. And then we can select all of that data. There it is. We can select all of this data and add it to a pivot table. This should also be a piece of cake if you've watched all videos. So we add our data to the data model because we're going to want to use a distinct count to calculate the different number of studios that people have worked for. So here's our pivot table. We drag in the name of the actor. There it is. And then we drag in the studio, and we get the number of studios that people have worked for. And there's one little thing that we still need to change, is we need to go to the pivot table properties, and we say we don't want to have the count, but we want to scroll down, we want to have the distinct count. And if this is done calculating, it takes a while. Now we can sort, and then we can see that Christopher Lee has worked for the highest number of different studios. I think it's 42. Yes, there it is, it's 42. So we have a lot of data in our database, and we can analyze it in different ways using VLOOKUP and using pivot table. We know that by now. But let's try to ask ourselves a different question. We would like to know for all of the actors, not the number of studios that they have worked for, but we like to know for every actor their Bacon number. I thought Bacon number was like a very familiar concept. I did the same exercise in my class here in Delft for 40 students, and I said, who knows what a Bacon number is? And like 2 hands went up. So apparently it's a little bit of a movie geek thing, so I'll explain to you what it is. An actor's Bacon number is the number of steps that an actor is removed from Kevin Bacon. So Kevin Bacon himself has Bacon number 1, and someone that has played in a movie with him, for instance Ed Harris in Apollo 13, he will have Bacon number 2. Someone that has played in a movie with Ed Harris, like Nicolas Cage in one of my favorite movies, The Rock, will have Bacon number 3 because his distance to Kevin Bacon is 2 hops via Ed Harris. So in this way we can chart everyone who has played in movies based on their distance to Kevin Bacon. So the number of hops, the number of steps from Kevin Bacon defines the Bacon number. We should be able to calculate this information in our little movie database, right? Because we have the information. We know who has played in what movie. But how to get this out? How are we going to process the information in such a way that we get a nice little list of each actor with their Bacon number? So I challenge you, before you watch the rest of the videos, to try this. And don't try it on this huge database, but try it on this little database. We will put this online in the course website. It's just easier to play with such a little spreadsheet than with an entire list of thousands and thousands of actors. So please don't watch the next video yet. download this, play with it, and try to see if you can come up with a way to analyze the Bacon number for each actor. Good luck! So we're calculating the Bacon number of a bunch of different actors in our spreadsheet. And to stay on topic, I want to say big spoiler alert. If you watch the rest of this movie, you know how to do it. So if you still want to try it, this is your second chance. Stop watching this now, download the spreadsheet and try to see if you can do it for yourself. It will really be a lot more fun than watching me just explain it. Okay, you're still here. I guess you've done your homework, so let's see how I solve this problem using a spreadsheet. Here's our database, or our spreadsheet, the little version where we just have a number of actors. So the first thing that we need, of course, is to determine who in our spreadsheet is actually Bacon. Well, that's pretty easy. We can just use a conditional formula where we say, is this actor equal to Kevin Bacon? If it is, he will have the Bacon number of 1. If he isn't, well, we could say then you have Bacon number 0, but that's not entirely accurate. Actually, the Bacon number of someone in step 1 who is not Kevin Bacon is not 0, but it's undefined. There's no way of connecting two actors. So we use a little dash for that instead of a 0, which is mathematically just more accurate, and it would also help us because in the rest of the solution we're going to use mathematical functions like the sum and the minus, and if we have 0 in there, it might mess things up. So in one step, the only one we can reach is Kevin Bacon. So he has Bacon number 1, and the rest we don't know yet. So based on this, we can see how far we can go. Let's go back to our list of movies, and it's pretty easy to determine now which of the movies have someone in them with a Bacon number that's not undefined. We can just do a VLOOKUP of the list of actors. There we go. Of course we use false because we're using a direct connection. Don't forget, select this and hit F4, and then we can drag this formula down, and the movies that have Kevin Bacon in it will now have a 1 after them. For instance, Crazy Stupid Love has Kevin Bacon in it, so it gets 1. So what we would like to do now is propagate this 1 to the entire movie, so we can see who else in the movie will get the Bacon number 2 because Kevin Bacon is in it. And what we like to have in the movie worksheet is a Bacon number not of an actor, but of a movie. And we can of course do that again with a VLOOKUP. If we look here, we can see who is in the movie. And we use a little bit of a dirty trick for this because we can use the SUMIF function. We just sum all the values for a given movie, and we sum the steps that we currently have. And if we sum a 1 and 2 dashes, the result will be 1, and if we sum just a bunch of dashes, the result will be 0. So this SUMIF will actually result in 1 if someone in the movie has a Bacon number, and it will result in 0 if no one in the movie is connected to Kevin Bacon. So if we drag this down, you see those two movies, Crazy Stupid Love and Wild Things, have 1, and the other movies have 0. So we are slowly getting there because we know now in one step what actor, Kevin Bacon, and what movies can I reach. So we can continue this in a second step. So now we want to have the correct number, not just for the Kevin Bacon version of the movie, but for all of the other actors in the movie. And we can do this again with a VLOOKUP. We're going to go to the movie worksheet, VLOOKUP, and we find the associated Bacon number for the movie. And we can hit F4, and then we can drag this down. So we're close, but here we have zeros because the VLOOKUP in the other worksheet, the SUMIF, resulted in a 0. And that's not what we want to have a dash. So let's see, if this VLOOKUP is equal to a dash, then the result should be another dash. Oh, I'm sorry, if it's equal to 0, it should be another dash. And otherwise, it should be equal to the VLOOKUP, but plus 1, because Kevin Bacon's number is 1, and everyone who has been in a movie with him should get the number plus 1. So now we have the right numbers in the right line for all the actors. And if we just get this in the actor worksheet, we will have the correct calculation. So there we go. Step 2, what we can just do is use another VLOOKUP, and we're going to look for the actor. And now we take the fourth column, the D column, because there we have everyone who has been in a movie with Kevin Bacon will have 2, and the others will have a dash. So this is almost correct. We see that those people that have a 2 are indeed the ones who have been in a movie with Kevin Bacon. So it almost works. There's just one thing that's still a little bit strange, is that in the second step, Kevin Bacon now has 2, and that's because we went from him to Crazy Stupid Love and back. But that's not really fair, because he already had the Bacon number of 1. So what we really need to do is take the minimum of what we have already calculated and what is in this extra step. And you see that in a previous video I forgot to hit F4 there, so I have corrected that now as well. So we see Kevin Bacon now has 1, all the others have 2, but unfortunately because of the use of the minus operation, we now get an error value. I don't know why this is, but if you have 2 minuses, if they're in different worksheets, apparently Excel gives an error. So we add an if error around it. If we get an error, then we write a dash, and otherwise we use the minus. So we have done it. Now for one step we've calculated 1 Kevin Bacon, and everyone that has been in a movie with Kevin Bacon now has Bacon number 2. We would still need to continue this entire step another time if we would want to do it for 3 steps, and then for 4 steps, and then for 5 steps. So can we do this? Yes, we can. You've just seen me do it. However, if you continue this calculation, and I encourage you to try to continue it by yourself, then you'll see that for 3 steps, you will need 8 auxiliary columns, 8 conditional formulas, 3 minuses, and 8 VLOOKUPs. So that's maybe not really what you want, and then you're just at 3 steps. And I've looked it up, and apparently the highest number that an actor in Hollywood has is 12. So if you want to continue this calculation for 12 steps, then we need like 25 VLOOKUPs. So probably we're not really on the right path here, but it is possible. So we've calculated the Bacon number in the previous video in Excel, which is possible, but takes us a lot. I'm not afraid to admit that it took me about 5 hours to come up with this solution, and I'm quite handy with Excel, so this is not a solution you want. Actually, I hope that in your mind you have something like this, the no Excel alarm. If in your daily life you're making a solution that takes you more than 10 VLOOKUPs to put together, then something is off. You should really be thinking, am I using the right tool for the job? Is this still the best way to do it? So of course then the question arises, what should we use? What is a better tool to use than a spreadsheet? What about programming? Isn't it easier if you use a programming language? Because with programming you are not limited to the rows and columns of Excel. You can do anything you want. This might be a good solution for a problem where Excel is not entirely fit. However, I'm a little bit like a hobbit. I like to stay in my comfortable shire. I don't want to leave my comfortable Excel home to go to a programming language that I'm not familiar with. Of course, we could use VB. Visual Basic for Applications is a programming language that is embedded right in Excel. Maybe you've been working with it before. And this you can use is a programming language to automate your spreadsheets, to calculate things that you cannot do with a formula. This is a possibility. If you have been working with VBA before, I challenge you again to try to solve the Bacon puzzle with VBA. This should be a lot easier than using formulas. However, that's not what we are going to use in this course. What we are going to use to automate our spreadsheet is a language called Python. So why Python? One of the reasons that I like to use Python is that it's currently the #1 programming language taught at universities. So in a few years there will be lots of people around the world that really know how to program Python. It's also quite easy to learn. You'll see that in the examples in this video, that the syntax, the way you write the programming language, is quite easy. And also there's a big ecosystem around Python. That means a lot of small Python programs called libraries exist in the world to solve problems. And if you have such a problem, you don't need to write the Python yourself. You can just use the programs other people have already created. So these are all reasons that I prefer Python over VBA. But VBA is also a good programming language that you can certainly use for this type of problems. But if I want to use Python, do I have to go away from my spreadsheet home? You can. You can use Python totally separate from Excel, but then you have to do a lot of learning. You have to migrate your data from a spreadsheet probably to a text file. So I don't want that. I want to have Python and Excel, both of them. Luckily, there's a solution. There's a cool program that's called DataNitro that allows you to use Python in Excel. Much like VBA, you can just script your spreadsheet with Python. This solution, unfortunately, is only available for Windows, but there are alternatives for Mac and for Linux. We will put links to the alternatives on the course page. So let's try to use DataNitro. Here you can see it. If you had a keen eye, you've seen that in the screenshots of one of the previous videos, there was a DataNitro plugin. So it's right there in Excel. And if you go there, if you go to the worksheet, let's click it. If you click Python shell, you get something like a calculator where you can type formulas like 3 plus 5, much like you can type formulas in Excel. But you can also refer to the spreadsheet. You can do something like C2 plus 5, but you don't do C2 as you do it in Excel. You have to directly call the value. So you say, give me the cell on C2, the value, and add 5 to it. And it's not just reading, you can also write to the spreadsheet, as you see me do here. Let's put hello in A1, and then you see that not just A1 has changed, but also all the values that depend on it. So you change a value, and then the spreadsheet calculation kicks in, and everything is recalculated. But let's quickly put it back to Kevin Bacon, because otherwise our nice Bacon calculator is messed up. So this seems to be a good solution that might help us to solve our Bacon problem with Python. And that's what we're going to do in the next video. So let's see how we can use Python to solve our Bacon example. Let's go back to our spreadsheet and let's have a look at the parts that we like. Like this simple VLOOKUP is pretty okay. However, this is problematic. It has 2 lines and also it depends on those ugly sum ifs in the other worksheet. So we want to get rid of that and replace that with Python. So let's take this column, select it, and let's copy it back as values, just so it's like a test, so we can see if our Python will do the exact same thing as the original formulas. And we can get rid of that and make some room for our Python code. Steps in Python. So the question is now, what are we going to do here? What actually are we calculating? And if we think about it, what we're going to calculate here is for each of the movies, is there an actor in it that has a Bacon number that is unequal to a dash, that has a defined Bacon number? And in order for us to figure out what to place there in Python, we're going to need the theory glasses. So let's go to the blackboard and have a look at what exactly we are calculating. So what we'd like to have is a function like sum that calculates based on the name of the movie, the list of actors that are in it, their Bacon numbers. So what is the type of that function? So let's say all of the steps for a given movie, we put in a movie. And what we want to get out is a list of Bacon numbers for that movie. So for instance, for Crazy Stupid Love, this list would be 1 dash dash. These are the first 3 rows currently in the spreadsheet. So what we get is a list of things. So what is in this list? It's either a dash, either it's undefined, or it will be a value. And if you remember from the previous types, lists are quite hard to work with in spreadsheets. You have to use array formulas for that. But in Python's, lists are very easy. They're one of the built-in types, and they're very easy to manipulate. Something like this will be easily done in Python. If we have that list, 1 dash dash, what we need to calculate is the Bacon number of that list. So let's call that function next step. What we put in here is this list. So we put in the list of the Bacon numbers of the actors, and what we will get out is a value. So these are the things that we're going to program in Python. Give me a movie and I will give you a list of the Bacon numbers of the actors in it, and give me that list and I will give you the Bacon number of everyone that is in this movie. So we don't need the theory classes anymore. Let's go back to Excel and have a look at how function defining works in Python. So let's power up a shell. We click Python shell in DataNitro, and now we can define functions. So let's start with an easy one. We say we want to have a function +1 where we put in something, and the result is that something +1. So this is very much like defining our own sum function or our own minus function. We can put something in and we get a result. For example, now if we ask Python, what is this? It knows that +1 is a function, and if we put something in, for instance, we get the +1 of 5, the result is 6. So it's a bit cryptic maybe, but the idea is that you define your own functions, and you can say, what do I take in? The number x, and what do I return? That number x +1. And this is the exact same thing, the function defining, that we're going to use to address our Bacon issue. So let's make another shell and let's make another function. And you know what function? The functions that we defined on the blackboard. So we start with all steps. All steps is a function that takes in the name of a movie and it returns all the Bacon numbers of people in that movie. So for example, for Crazy Stupid Love, the result of this function would be 1 and a dash and another dash. So we're going to traverse all the lines in our spreadsheet and see if we have a match for our movie. Initially, if we start with the first line, of course, we haven't found any matches yet. And then with the for syntax function, this is a Python thing, we can use everything, we can address every line. So we start at the second line and we go until the 12th line, and at every line we're going to look, is the value in the second column, so in the row that we are in, which is I, our variable for the loop, in the second column, is the value of that thing that we are inspecting equal to the movie we have put into our function. So this should remind you of the SUMIF function, where we're summing a bunch of lines only if it matches a certain value. Well, here we are grabbing a piece of values together only if it matches a certain value. So what are we adding to our list? Not the name of the movie, but the column right next to it. So the cell on the row we are inspecting in the third column. If we have a match, we add this to our list with the append function. And if we're done, if all of the rows have been inspected, then we return the list of steps. So remind yourself of, like the +1, we put in 5, we get back 6. This is, we put in a movie, we get back a list. So we can put the result of this into a variable. Let's try that for the movie Crazy Stupid Love. We make a variable called the steps of Crazy Stupid Love. And what we're going to put in that variable is the result of our function. The all steps applied on Crazy Stupid Love, but here we should add quotes because it's a string, a text value. So we hit enter, and now the value is saved in our variable. And if we ask Python now what is in this variable, the result will be 1 dash dash. And this is exactly what we wanted, right? The result of Crazy Stupid Love is the list 1 dash dash. So the first part of our problem is solved, but it's still solved in the Python world. And we would like to have this value back in the spreadsheet world. So we can do that. We've seen that before. We can edit the spreadsheet from Python. We can say the cell at the second column and the fourth row, second row and the fourth column should be the value that we have in our variable. And if we hit enter now, immediately the value has been updated. And what you see here is that Python can put an entire list in a cell. If we want to do that with Excel, we have to use array formulas, as we've seen in videos of previous weeks, and Excel cannot put an array, a list, in one cell. You have to give it space to fill up all the cells. This is not the case with Python. We can just take the whole list and put it in a cell, which is a lot more convenient if you are using a lot of list operations like we are. So let's continue with the second half of our problem. I have cleared the shell now, however we can still see all the functions that are there. Python has remembered them, so we still have the all steps function, and we're going to make a new one now. We're going to make the function next step. As we saw on the blackboard, this is a function that takes in the list that we have just created and returns the next value. So we're going to traverse the steps, 1 dash dash in this case, just as we have traversed the rows in the previous example. So we use for again, a Python construct that's used for looping, and we're inspecting all of the elements in our steps list. So if we see something that is not a dash, like a 1, we know what the result is, right? Then the result should be that value plus 1. So if we see something unequal to, that's the exclamation mark syntax, then we know that we have to return plus 1. But what if we see a dash? We don't know what to return because the next row could be a dash or it could be a 1. So if we see a dash, we don't know yet. However, if we've only seen dashes and we haven't returned anything yet, then we're going to return a dash because that exactly expresses what we want. If everything is a dash, the result will be a dash. So we have a function, it is defined, and we still have our variable 1 dash dash that we've made in the previous slide. So now we can use that. We can call this function on the variable. And that goes like this, like plus 1, we just say, put the variable in and we get the result. So if we put this list in, our result is 2, which is exactly what we wanted. If we have a movie with 3 actors, one is Kevin Bacon and the other 2 have an undefined Bacon number, then this movie will give the Bacon number of 2 to everyone that has played in it. So far, we've been using only the Python shell option, but what we can also do is use the editor, and then we don't have to type in the functions on the crazy little line thingy. We can just type them in a text file and save this. Just as you save a spreadsheet, you can also save these Python files, and that's of course a lot easier than typing them in, because once you've closed the shell, all the functions that you have defined are gone. So we've put everything, same function definitions now, in a file, and from that file we can run it and put it back into the spreadsheet. So again, we're going to use a for loop, and for all of the lines we're going to print, to make it easy, we're just going to print the number of the row, just so you can see how it goes. So we say the value of I and 4 is going to be just I. So if we made that, we save the file and we hit run, whoop, you see at one go all of the functions are, all the i's are there. But I've made a mistake. I was using to 12 all the time and I forgot that it's until 12 and not until and including 12. So this should actually be 13, and so has the function. So now we've gone into 13 and you see all of the rows are filled. But of course we don't want the I there. What we like to have is the result of those 2 functions that we've just defined. So let's start with the all steps again. So we take the value from the second column. So now we have the movies. That's the first step we need, because the name of the movie is what we're going to put into the all steps function. So here we go, all steps. In it, we're not using a string anymore, but we get the value from the spreadsheet. It's nice, right? So now for every movie, we have a list of all the actors that are in it, and we just need to put that list into the next steps function. There we go, we put in the list, and we hit run. Look at that, the result is exactly the same as the result that we have obtained with all the VLOOKUPs and the sum ifs. But instead of using a lot of formulas, we just used a little bit of code to calculate the values. Why is this code easier than VLOOKUP? Because we use constructs like a list and a loop that are not native, not natural to spreadsheets. These are constructs that are very common in programming. However, if you want to do something like inspect all of the lines of my spreadsheet and do something in a certain case, this is not something that spreadsheets are made for. They're made for calculation and not really for inspecting values and then changing them continuously. So these are scenarios where programming languages are just a little bit easier. So what we can do now, we can get rid of those. We don't need those ugly sum ifs anymore. We can select them and be done with it. Go away, we don't want to see you anymore. And here, notice how I've put back the VLOOKUP secretly while you weren't looking, just to show you it one more time before we get rid of it too. So we don't need those values anymore. But we don't need to get rid of all of the formulas. Some of them are still fine. The VLOOKUP, for instance, the first one that we use, it's fine. It's a simple function, you can use it. But some parts, the ugly parts, we have removed now and replaced them by this short Python code. And you see me in this video, I only did the second step. So your challenge for the rest of the week is to extend this Python program so that it doesn't just work for 2 steps, but it works for an unlimited number of steps, or let's say at least until 12, because that's the highest Bacon number that there is. So good luck with that homework, and see you next week.